in Objective Caml. OCsigen is a research project of the PPS laboratory. I just want to say a few words about PPS. PPS, for those who don't know PPS, I think it's an important place for the OCaml language. In the list of participants today's meeting, I counted, I think, 11 people from PPS. And among PPS members, there are very important people from the OCaml community. You may not know them because they are not writing on the Caml list, but for example, Guy Cosino is one of the fathers of Caml. Pierre Lucurien invented the categorical abstract machine, the CAM, which gave its name to the language. Jérôme Brouillon implemented the object layer of Caml, and there are many other people in the laboratory working on packaging or developing application in Objective Caml. The aim of the laboratory is to explore the links between proofs, mathematical proofs, and programs. We are mainly doing theoretical research about this. Well, you probably already know some project about web programming in OCaml. OCamlNet, for example, is the wonderful set of libraries with all that you may need to program with OCaml for the web. We are using a few functions from OCamlNet in OCsigen. It is written mainly by Gert Stubman. OCaml is an Apache module for writing website with Objective Caml, etc. There are other projects, maybe I forgot some. So what's the difference between OCsigen and this project? A few years ago, the Belgian artist drew a painting about this, to explain this, where there was written, OCsigen is not a web programming tool in OCaml. But what you... It's very, very bad. What he was meaning is that, well, our goal is not to write another web programming tool in OCaml. Our goal is to make research about web programming and find new programming techniques for the web to improve accessibility and robustness of website. We want to introduce high-level concepts for simplifying the programs, and we want to fit the new needs of web programmers for the new kind of website we call Web 2.0. So at the beginning, we wanted to create our own language, but we discovered that many things can be done in OCaml itself, and now we are working on two twin projects, OCsigen and WebPsychola, website conception language, led by Jean-Vincent Lodo. He will be here today afternoon. WebPsychola is more independent from the language, and OCsigen is an implementation of the concept in Objective Caml. Our main idea is functional web programming, more precisely what we call continuation-based web programming. We are not the only one to work about this, and there are several other projects. Well, but very few projects with respect to the huge number of web programming tools, of existing web programming tools. Okay. OCsigen is organized as a free software project. We are trying to build an open source community around the project, and we already have some users. I can show you example of websites that have been written by our users. NURPA wiki written by Jan Elsten. This is a wiki with an integrated to-do list. You can edit the page. Oh, sorry. Okay. You can edit the page and you can add the task you want to schedule. Well, you can mark them as completed. You can schedule them for another date, etc. Another website written with OCsigen is Landium Light by Dario Teixeira. This is a content management system. You can write forums. See what OCsigen is. We are almost at version 1. I hope we will release the version 1 in a few weeks, maybe a release candidate in about 3 weeks, 4 weeks, I don't know. For now, we have a full-featured web server, an extensible web server. We have one module called Eliom, which is the most innovative part of the project for web programming, functional web programming, continuation-based web programming. And we have a set of libraries called OCaml for writing websites with OCsigen. The web server implements obviously the HTTP protocol. And we have a powerful extension mechanism that makes possible to extend the server very easily and to use the server as a basis for other projects. Obviously, we can handle static page. We have access control, compression of data, a CGI module to run CGI script. Even if that's not what we want, you may want to use CGI scripts. We have a reverse proxy, Eliom, etc., etc. The main distinguishing feature of OCsigen is the use of cooperative threads. Well, I don't have the time to make a course about cooperative threads today. I will just say that it's a concurrency model that fits very well functional programming. And here we are using a library called LWT, written by Jérôme Bouillon, that implements cooperative threads in modalic style. Well, just one example, if I want to do a request, then use the result, I will write a cooperative version on the request. Instead of writing this, let R equal request in, I will write the request function in cooperative style, then bind the result to the function that will parse the answer. So you are, in fact, describing a dependency relation between very elementary computation. And I think that's a really good way of programming. It's really, well, I really advise you to try it, even for other projects. And we will release LWT as a separate package to allow more people to use it. LWT is also used in Unison. And actually, we are using a mix between cooperative threads and preemptive threads to enable the use of non-cooperative libraries. Okay, let's now go to the main part of my talk, to concrete things. And as you are all OCaml developer, I think I can show you some code, and we will try to write a small website together. So let's try to write a forum. A forum is a website. For the first version we will have 2 pages. The first page is with a list of messages, and the second page with that displays one message and maybe the list of comments. We will not implement comments today. the first thing you want to know is how to write your HTML. And almost all web programming tools are using the same method for that. They just write, they just output strings on the standard output. Okay? But that's not what we do, because we want to check the pages. We want to ensure statically that the pages we generate respect norms by the W3 consortium. Well, actually, Eliom is written in a modular way. You can choose the output module you want. There is a text output when you want to just to generate a typed page, or if you don't want to generate HTML to something else. We have one module called OCHTML to type check XHTML with OCaml polymorphic variants. We also have for this module a syntax extension that allows to use the usual XML syntax to write your pages. And there is also an OCaml juice module to use OCaml juice to type check your pages. OCaml juice, you will know that it's an extension of OCaml that adds XML types to the language written by Anna-Frisch. Okay, so let's go to the code. I will show you one example of page written with the HTML module. I have two versions of the same page. The first one is using the syntax extension. The second one is using some function, some constructor function. Let's try to modify my page. For example, this one. Here I put P instead of title. And make. I'm trying to compile it, and it says basically that this expression cannot blah blah blah. It has type P, and it is not compatible with. So this is the set of tags we are expecting inside head, and you cannot put P inside. Okay. Well, we have other output modules. Yes.
What should happen if you gave twice? If you gave two type elements, two title elements in the.
Well, actually, with the syntax extension, we cannot check that. Okay. With this syntax, you can check that. Because you see that head is expecting two parameters. The first parameter is as type title, because title is mandatory inside head, and a list of something, and here you can put several times. Well, you have several other output modules, one for style sheet, one for file, one for outputting for doing redirection. Yes.
How do you handle stuff such as, well, not in HTML itself, but in XML, or don't you just handle XML?
Well, you can use any XML with OCaml juice.
Oh, OCaml juice has different type systems. So. Okay.
Well, if you want another XML with polymorphic variants, you need to write to implement it. Okay. Now, the main idea of functional web programming is that clicking on a link on a web page, or sending data through a form, is like calling a function. Or sending parameters through a form is like giving parameters to a function. So we have a set of functions waiting on the server, and we call this function services. To create a new service, I'm using the function new service. Here I'm creating a first service. I want it to be available as the main URL of my website. I can put here another URL if I want. My service is not taking any parameters, the first one, and then I register on that service the function that will generate the page. Here I'm using the create page, that create page function. Well, let's have a look at it. Well, now I compile the website. I need to write my configuration file and add in my configuration file my CMA here. Here I have three versions of the website. You see, the first version is on directory V0, the second one V1, and the third one V2. So let's have now I'm running OCsigen with that configuration file, and I think it's on port 800. Yes. Okay, that's my first page. There is a function, I didn't show all the functions. There is a function display message list that displays the list of messages I have in my database. Okay, let's now go to the second version of the. Well, this is the second page. I want to write a second page with one parameter of type integer that will display one message. So this. Well, this is exactly the same. I just use here that notation to tell that my service is taking one parameter named n of type integer, and then I'm registering that function on that service. You see that my function all takes three parameters. The first one are server parameters, all the information about the request. The second one are get parameters. The third one are post parameters. Get parameters are the parameters in the URL. Post parameters are parameters that are sent in the body of the HTTP request. Here, n as type integer. Here, as type field. Okay. Now, what if I want to write a link towards that service? I will use the aid function with 1, 2, 3, 4 parameters. The first one is the service I want to go to. SP, the famous SP parameters, server parameters. The text of the link, and the last parameter is the parameters I want to give to my service. Okay. The here 4 because my page is waiting for an integer. So you see that the type of the last parameter depends on the service. Okay, that's a good example of generalized algebraic data type. Okay. As a consequence of this, it is not possible to have broken links because I'm not using the text of the URL. I'm doing a link towards a service, which is an abstract data type. Okay, and there is a possibility to have static checking of the type of parameters and check that form corresponds to the service on which it runs. Okay. Now I want to implement version 1 of my website. Well, this is the same with the style sheet. I want to implement a page that allows to create a new message. Display a text area, and I can write my message, then enter, and it asks confirm yes or cancel. Well, let's do it again. Here I split my window and I'm trying to create another message, and I'm writing another message here. Now I have to confirm the same page, but the first one is to confirm the first message. The second page is to confirm the second message. What if I click? Well, if I click on cancel, I will go back to the main page. But if I click here, I want to add the first message on the database, and if I click here, I want to add the second message on the database. Okay. But right now, where are the messages? Are they on the server? Yes, they are on the server, but where? Are they in the in session data? Well, actually, that's a very tricky feature to implement, and there are famous examples of websites that are buggy because of that. For example, the website of the SNCF, the French railway, when you choose 2 tickets and then you decide to buy the first one, you will buy the second one. I don't know if it's corrected now, but a few months ago it was like okay. That's a famous problem called the back button problem, and it's a problem that is really easy to solve using functional programming because it corresponds to the notion of continuation. It corresponds to the notion of continuation. That problem has been described by Christian Keinec. I think that was his name on the slide. If you click on the back button, you are going to another continuation of the program. So where is the message? Now you can answer the question. It is on the server. It is in the closure, in the environment of my service. Okay. How is it implemented in Eliom? In Eliom, we implemented this by allowing to create dynamically new services. We call them co-services. For example, here is the implementation of that feature. I have that service that takes the message as post parameter, and it will dynamically create a new co-service and register the function that will register the message in the database. This register message is registered in the database. Okay. Okay. Now, remark that the link here, create a new message, is missing here. Well, actually that's because I forgot to write it. But you can see that it's not really clean like this. I should at least have used the same function to display the pages. Well, but that's something that what do we want to do here? We just want to add a message in the database. We don't really, when you click on yes, you don't really want to display a page. You want to add a message on the database and then go back to the first page of my website. So to do that, we introduce a notion of action. An action is another output module that does nothing. Well, that does something, but does not display any page. We just reload the current page. Another use of action is when you want to, well, I will show you the third version of my website. The third version of my website has a login box. I can log to my website, and I want to display the same page, but after having set some session data. This is another example of action. So, I think, I will I made. So that service, that action of connection, I want to have it on every page, and if I close the session here, I want to stay on that page. Okay? If you want to implement this with traditional web programming, or even with functional web programming with service and cost services, as I told you, you would need to implement a version of each service with post parameters, or at least to take into account the fact that each service may or not take login password parameters. To make this more easy, we added the notion of non-attached service, that is, services that are not bound to a precise URL. A service that can call from anywhere and that won't change the URL. It's not possible to do that with traditional page-based web programming, but here we can have that possibility. So we have every service or every sub-service may be attached to an URL or not. So we have a full taxonomy of services. I did not spoke about service with post parameter. We have service with get parameter and service with post parameter. I did not speak about session. Every service can be registered in a session table available only for one user. In that case, Eliom is putting a cookie automatically. So what I wanted to show is that it is really easy to write sophisticated behavior with very few lines of code. If you take the full website, version 2, it takes takes 156 lines for that website. It's very, very small. I can show you to conclude, here is a summary of the features, Eliom's concept. We have static checking of pages. We have a full set of service kind with a strong use of continuation-based web programming. An important thing is that we have a very precise control of URLs. You can choose precisely the URL you want, and you have concepts highly related to the concrete needs of web developers that allow to write, to reduce the number of lines of code. I did not speak about session. We have the mechanism of session with automatic cookie management, session service, timeouts, etc., etc. So now I told you that version 1 is almost ready. This is the first step of the project. We are working on other stuff. Now we want to write more dynamic website with something on the client. Our goal is to implement, using all in OCaml, a website that will with some part that will be executed on the client. Okay, that's for the next maybe in 2 years. Okay, thank you. Do you have questions?
So, from what I understand of your dynamically of your post services, when they saw the URL, it was something like a hash, wasn't it?
Well, it's not a hash, it's some...
with some big random number or something.
Yes.
So a few years ago, I think, I looked at links, and they seem to have a huge security problem insofar as their continuations were passed as, readable text, which if you have your credit card number or so, is not acceptable.
No.
Here you use
well, there is a difference with between Eliom and that version of links. I don't know if it's still the case, but they were sending the continuation in the page.
Yeah.
We are not. We are keeping the continuation on the server.
Yeah, so that brings me to my actual question: garbage collection. How do you garbage collect that?
Yes, we have. You can set timeouts on co-services, or you can tell that you want a co-service to be used only once or twice, etc. That's one way to solve that problem. But actually, you have the same problem as with any other web programming tools. It's not a problem with continuation. That's a problem if you want to keep some information in memory. We have that problem. So I think the solution is to limit the number of sessions for one user, limit the time for sessions for their services. Other question? Yes.
So when you say executing code of the client, you mean Ajax but without the buzzwords? Or?
Yes, but actually we don't know. We are exploring several directions, either generating JavaScript or using something else, plugin. Well, what would be interesting is to have something fast on the client, which is not the case with JavaScript. For now, we are exploring several directions. I don't know which one we will use.
Continuation-based frameworks sometimes have a problem of scaling because the amount of server state being kept. Have you had problems with that or addressed that in some way?
Well, basically that's the same answer. We need to be very careful about the number of sessions we have, but actually this is not related to continuation-based web programming. This is the same problem if you want to keep any data of memory. A closure is not bigger than the data you have inside. Actually, you have just the data and so enter to the functions. Usually, when you are using a database, you will put your data on the hard disk, so you don't have that problem. If you want to keep data in memory, you will have the problem, and you need to implement some mechanism to limit the data.
No, I was merely thinking about especially scheme-based frameworks who sometimes save a little bit too much state from the stacks.
Yes.
I didn't like that.
No, it's not the same thing, because scheme is using call CCs, using control operators they are saving the stack, and we are not saving the stack because we are using closure, and only closure. That means we are using basically continuation passing style. So we do not need to save the stack.
What happens when you upgrade your server for the user who is online, and what happens to the closures?
Yes, well, obviously if you shut down the server, all will be lost. So we have a mechanism to reload the website without shutting down the server. As you saw, we are delinking the module, so you can reload your module without shutting down the server. And if you need to upgrade your website, you will lose the session. But we have a mechanism of persistent session. You can do persistent session, so all the session won't be closed. Just co-services, but co-services usually have a short timeout, because of this problem of scalability. We don't want to keep them in memory for too much time.